Million years ago, something happened on Earth that almost turned our planet into a dead rock. We all know about the asteroid that wiped out the dinosaurs. That story's become part of pop culture and children's encyclopedias. But few have heard of a catastrophe so much more terrifying that paleontologists gave it a name that sends shivers down your spine. The Great Dying, an event that annihilated 96% of all life in the oceans and 70% on land. The asteroid that killed the dinosaurs took out roughly 3/4 of species, and we consider that an absolute disaster. The Permian extinction wiped out almost everything, forcing life on Earth to start practically from scratch. To grasp the scale, imagine the world that existed before this catastrophe. The end of the Permian period looked nothing like how we usually picture ancient Earth. All the continents had drifted together into one giant supercontinent called Pangaea, surrounded by a single ocean, Panthalassa. On land, synapsids, the ancestors of mammals, reigned supreme, not dinosaurs, which didn't even exist yet. Among them were gorgonopsians, predators the size of bears with fangs as long as an adult's hand. They sat at the very top of the food chain and knew no competition for millions of years. Alongside them roamed pariasaurs, massive plant eaters with bumpy armor plating like a mix of a hippo and a tank. And in the shadows of fern forests hid small cynodonts, quick little critters about the size of a rat. It's from these tiny creatures, hundreds of millions of years later, that all the dogs, cats, horses, and people on this planet would evolve. But back then, they were nobodies, just small prey for those who were bigger and stronger. Giant reef systems thrived in the oceans, just as diverse and teeming with life as today's coral reefs. Sea lilies, brachiopods, and ammonites filled every level of the water column, from shallow coasts to the deepest trenches. Trilobites, those legendary creatures that had already survived 4 mass extinctions over 270 million years, seemed practically immortal. The world was complex, rich, and resilient. It had weathered ice ages, continental collisions, and dropping sea levels. And then, this entire world was wiped out, almost completely, in a geological blink of an eye. What could possibly destroy a planet that had weathered blows for hundreds of millions of years? The answer lies beneath our feet, or rather, beneath the land we now know as Siberia. About 252 million years ago, the Earth's crust in this region began to crack open. But this wasn't your typical volcanic eruption, not a cone spewing lava like you see in the pictures. The Earth split open for thousands of kilometers, and magma began to pour out from these fissures. Geologists call this the Siberian Traps, from the Swedish word trap, meaning stairs, because the cooled lava formed step-like plateaus. The area covered by these eruptions spanned roughly 7 million square kilometers. That's larger than all of Western Europe, from Portugal all the way to Finland. If you think you've seen dramatic eruption footage, forget it, because the scale here was absolutely colossal. Imagine a landmass the size of Australia, with molten rock flowing out from every single crack. And this didn't go on for days or even years, but for hundreds of thousands of years. Rivers of lava, tens of kilometers wide, just flowed over everything in their path. The air temperature near these rifts got so incredibly hot that rocks would melt even before they touched the magma. Ash from these eruptions can be found today in geological layers all around the globe, from Antarctica all the way to Canada. Clouds of emissions enveloped the entire planet, and Earth's atmosphere turned dark for months. But the lava itself wasn't the main killer. It only destroyed everything alive within the eruption zone. However, the eruption zone wasn't the whole planet, and the real killer mechanism was invisible. The Siberian traps spewed colossal amounts of carbon dioxide, sulfur dioxide, and halogens into the atmosphere. Let us know in the comments what country you're from. It's interesting to see where we're being watched from and who this topic has grabbed. The first wave was sulfurous. Sulfur dioxide rose into the stratosphere and turned into an aerosol that reflected sunlight back into space. The planet's temperature plummeted dramatically, triggering a volcanic winter, and ecosystems accustomed to the warm Permian climate began to collapse. Land plants perished from the cold, herbivores lost their food sources, and the entire food chain crumbled behind them. But sulfur aerosols don't linger in the atmosphere for long, just a few years, maybe a decade at most. The carbon dioxide, however, didn't go anywhere. It just kept accumulating century after century. Once the sulfurous veil cleared, the exposed planet found itself under a blanket of greenhouse gases, and rapid warming began. According to geochemical research, the average temperature on Earth rose by 8 and possibly even 10 degrees Celsius. For comparison, today scientists are sounding the alarm over a warming of just 1.5 degrees, and this was 6 times more. The oceans heated up so much that they started losing dissolved oxygen, because warm water holds less gas. The ocean depths became anoxic, meaning completely devoid of oxygen. Marine organisms that had breathed oxygen from the water for millions of years began to literally suffocate. Corals, which need oxygen to build their skeletons, were the first to die, and the reefs crumbled like houses of cards. Mollusks and marine arthropods followed, left without shelter and food. The ocean, which had been the cradle of life for hundreds of millions of years, was turning into a warm, acidic, and dead broth. If you're curious to know what happened next, subscribe so you don't miss new stories, because we haven't even told you the worst part of this catastrophe yet. But even suffocation wasn't the final blow, because then a mechanism kicked in that gives modern climatologists sleepless nights. In the oxygen-deprived depths, anaerobic bacteria, organisms that don't need oxygen, began to flourish. Among them were green sulfur bacteria, which release hydrogen sulfide during their life processes. This is that same rotten egg-smelling gas, only in concentrations lethal to all living things. Hydrogen sulfide began to rise from the ocean depths and escape into the atmosphere. Paleontologist Peter Ward from the University of Washington proposed a hypothesis that the sky above the oceans changed color at this time. It might have taken on a greenish or purplish hue due to the mass of hydrogen sulfide bacteria multiplying in the water. Imagine this scene, a green, toxic sky above a dead, hot ocean with a crimson glow of lava rising from cracks in the earth beyond the horizon. This isn't a scene from a sci-fi movie. It's a reconstruction of what Earth looked like 252 million years ago. But even the hydrogen sulfide in the atmosphere triggered another spiral of destruction. It began to destroy the ozone layer, that very shield protecting all life from the sun's ultraviolet radiation. Plant spores from that period, found in geological layers worldwide, bear traces of mutations caused by ultraviolet rays. This means that even organisms that survived the cold, heat, suffocation, and poisoning were exposed to a flood of cosmic radiation without any protection. Earth ceased to be habitable simultaneously on all levels, in water, on land, and in the air. Each subsequent blow was worse than the one before, and each new factor amplified the others. Scientists call this a cascade of positive feedback loops, where a system destroys itself at an accelerating rate. If it blows your mind how one eruption could kick off such a chain reaction, let us know what you think in the comments. Which theory do you find most convincing? But back in 2015, a team of researchers from the Massachusetts Institute of Technology published a paper that added a whole new layer of horror to this picture. They discovered that the volcanic magma of the Siberian Traps, on its way up, passed through thick layers of rock rich in coal, oil, and limestone. The superheated magma literally ignited these deposits, and they started burning deep underground. Just imagine a fire that isn't raging on the surface, but within the Earth's crust, several kilometers down. It's impossible to put out because the fuel and the source of the fire are all around. The burning of these organic rocks released massive additional amounts of carbon dioxide, methane, and toxic compounds into the atmosphere. The researchers found traces of fly ash in Siberian rocks from that period, which is characteristic specifically of coal burning, not volcanic activity. This is direct proof that an underground fire of planetary scale was raging beneath the surface. Essentially, Earth burned through its own fossil fuel reserves long before the first human ever appeared. That very oil and coal that we extract and burn on an industrial scale today, they burned once before. This happened 252 million years ago, and the result was the near total annihilation of life. In 2018, an international group of geochemists discovered abnormally high concentrations of mercury in the boundary layers between the Permian and Triassic periods worldwide. Mercury is a marker for major volcanic events, and its traces were found in rocks from Canada to China, from Australia to Greenland. This means the poisoning was global. Not a single corner of the planet remained untouched. But the most disturbing discovery of recent years is that the extinction wasn't one catastrophe, but two. Studies by Chinese and American paleontologists revealed that around 60,000 years passed between the first and second extinction waves. The initial blow devastated terrestrial ecosystems, and the second one finished off the oceans. 60,000 years between these two impacts sounds like an immense span by human standards, but for evolution, it's incredibly brief. This was just enough time for surviving species to begin rebuilding their populations, to start colonizing the newly vacant niches, and to begin constructing food chains anew. And then it all happened again, with the second blow proving even more merciless because it struck organisms already weakened by the first catastrophe. This means that life on Earth was indeed trying to recover after that initial hit, and it was almost succeeding. But the planet struck again, and this time, there was nothing left for the survivors to cling to. Trilobites, which had persisted on Earth longer than any other complex animal, vanished forever. 270 million years of evolution, 4 mass extinctions survived, and it all came to an end in the Permian strata. Gorgonopsians and most large synapsids were wiped from the face of the planet. Reef ecosystems, which would later take 10 million years to recover, ceased to exist. Entire forests disappeared from the land, and their place was taken over by fungi, which fed on the dead wood. In the geological layers of the early Triassic, paleontologists find what's called the fungal spike, a stratum where fungal spores vastly outnumber plant pollen. This signifies that a period arrived on the planet where there was more dead matter than living, and the main rulers of the land became organisms that processed corpses. Some scientists describe the early Triassic Earth as a graveyard planet, where the only thriving life forms were scavengers and fungi. Earth transformed into what paleontologists sometimes refer to as a dead zone. This was a period lasting millions of years, during which the geological record barely contains any traces of complex life. Temperatures remained extremely high, for another 5 million years after the catastrophe's peak. It became so scorching hot at the equator that large animals physically couldn't survive there, turning the tropics into a barren, lifeless zone. Life clung on only closer to the poles, where the temperature was just a little bit more bearable. But it was from this very ash that everything we know today grew. Those few synapsids that survived were small, insignificant, rat-like creatures. What saved them was precisely what made them so unremarkable. Their tiny size, their ability to hide in burrows, their low need for food and oxygen. Those traits that were considered weaknesses for millions of years suddenly became their only ticket to survival. It's from them, millions of years later, that all mammals, including us, would eventually descend. Archosaurs, another group of survivors, would claim the emptied land and, in time, give rise to dinosaurs. The Permian catastrophe acted as history's greatest natural selection event, killing off the strong and leaving alive those nobody even noticed. So it turns out that dinosaurs, mammals, and ultimately humans exist only because the Permian catastrophe cleared the stage. Without the Great Dying, evolution might have taken a completely different path, and intelligent life might never have emerged. We are living in a world that was born from the most massive biological disaster in the planet's history. Every species, every tree, every animal around us is a descendant of those few who managed to survive hell. And that's what truly makes you stop and think. The mechanism behind the Great Dying wasn't some unique cosmic event. It wasn't an asteroid hurtling in from the depths of the solar system. It was carbon dioxide, it was warming, it was ocean acidification, and the loss of oxygen in the water. These are the very same processes that climate scientists are recording right now in the 21st century. The scale difference is still enormous, but the direction matches with terrifying accuracy. Do you believe humanity is capable of learning from mistakes that are 252 million years old? Or are we doomed to repeat someone else's script? In 2005, oceanographer Lee Kump from Penn State University published a groundbreaking paper. He demonstrated that beyond a certain warming threshold, the ocean can shift from an oxygen-rich state to a hydrogen sulfide-rich one. This critical threshold isn't as far off as we might wish to believe. The Siberian traps erupted for hundreds of thousands of years to push our planet past its tipping point. We've been pumping carbon dioxide into the atmosphere for a mere 200 years, but the sheer speed of this process is alarming. In some estimates, this speed is comparable to that ancient catastrophe. In 2021, a team of scientists from the University of Burgos in Spain ran a simulation. Their results indicated that by the end of this century, carbon dioxide concentrations could reach levels not seen since the late Triassic period. Our oceans are already losing oxygen. This phenomenon has been recorded by monitoring stations in both the Pacific and Atlantic Oceans. Dead zones in coastal waters, where oxygen levels plummet below what marine life can survive, are expanding with every passing decade. Over the last 50 years, their area has quadrupled. It's a familiar mechanism, but this time, instead of the Siberian traps, it's factories, power plants, and cars driving the change. Paleontologist Peter Ward has dubbed hydrogen sulfide extinctions the #1 killer in Earth's history. By his calculations, at least 3 of the 5 major mass extinction events were triggered by this very process. Volcanoes, carbon dioxide, warming, oxygen loss, hydrogen sulfide, and then the cycle repeats. The asteroid that wiped out the dinosaurs turns out to be the exception, not the rule. The rule is far more terrifying because it implies our planet is capable of self-destruction without any help from outer space. Earth holds a record of every catastrophe within its geological layers, and the Permian boundary is the clearest chapter. Geologists find this evidence in rock strata across southern China, in the cliffs of South Africa's Karoo, and within the mountain rocks of Italy's Dolomites. Everywhere, the scene is exactly the same. A rich, diverse layer of Permian life abruptly disappears, and above it, emptiness begins. A thin layer of rock where life just stops. And then for a long, agonizing time, for millions of years,